Hello students, welcome back to online physics lesson. If my voice is clear, please write on the Zoom message. It's okay, write to me if you hear my voice clearly. Okay, good. So today we will see uh, distance and displacement. Uh, Yesterday already we start motion, and today let's see what is the meaning of distance, what is the meaning of displacement in physics. Uh, Here, distance is the total length of the path traveled between 2 points. Distance has no direction, thus no sign. That means it's a scalar physical quantity. On the other hand, displacement is the change in position of an object. For example, let's say the object starts from, let's say one object starts from this point and move to this point. And let's say this is the object, or move towards to this position. Then let's say this one is x naught. X naught means the initial position, and x final, it's the final position. That means we define displacement, the change in position of an object. The displacement is equal to the change in position of an object, which is given by x final minus x initial, or initial position. Okay. On the other hand, let us see a brief review about distance and displacement by comparing uh, oh sorry, let me insert the one. Here we go. Let's see what's distance. Distance, displacement. Distance, let us say s, okay, or we can say x, and displacement s with arrow indicates a vector physical quantity. So here distance is a scalar physical quantity. But in the case of displacement, it's a vector physical quantity. The SI unit of distance is meter. The SI unit of distance is meter. Again, kilometer, we can say kilometer, let me say kilometer, miles. In the again for displacement, its SI unit is the same as the SI unit of distance. That means meter, kilometer, and miles. Okay. The other point, distance has only magnitude, magnitude. But in the case of displacement, displacement has both magnitude and and direction, because displacement is a vector physical quantity. What do you mean by magnitude and direction? Let's see. Let us say 7 distance, or let's say sorry, let a man, this car moves from this initial position x naught to, or s naught, we can say s naught, initial distance, x and s, no problem, we can use to represent the distance or the displacement. And let's say here the position x final, how many this object move from this point to this point, let's say 7 meter, but we put this we see the direction means, let's say this is the vertical y and the horizontal x. Always we know that this is x, the positive. That means sometimes we say east, west, north, south. Again we can write this as right, left. Okay, this north, south, east, west, these are the directions. The magnitude means the value. Magnitude means its value. That means in the case of 7 meter, this object moves from this position x, oh sorry, this one is x final, x naught to x final, or this position to this position, it goes from west to east. That means we can express the values of the displacement for this case. 7 meter from S initial to S final, and the direction is from towards east. That means the distance, if the object moves from this position to this object moves from to this position, let's say 7 meter, the direction is towards the east, so the distance is 7 meter only. What about the displacement? The displacement is equal to 7 meter towards where? We can say east, or we can say right, because we have to put the direction due to its vector quantity. Okay, that's the difference. Okay, the next point, look at these examples. The man moves from this position to this position. then from this position to this position, the direction is towards east. When at this position the distance was 1.5 meter, and when she arrived at this position, the S final or X final position, this one X naught, let's say X, the initial or the position, uh, at this point the distance 3.5 meter. Then the displacement, let's say the displacement is equal to the change in position, which is equal to X final, the final position, minus the initial position, which is equal to 3.5 meter minus 1.5 meter, which is equal to 2 meter towards where? Towards the east. We can say towards the east, or we can say towards the right. But the distance S, let's say without arrow because of its scalar quantity, the distance for the woman traveled is only 2 meters without direction. Okay. The second example, inside the airplane, this man moves from this position to this position, but the plane moves towards the east direction according to when we put vectors on the xy plane, but the man moves towards the west direction. Now the passenger moves from his seat back of the plane, and his location is relative to the airplane given at by x. Then look at this position. It was 6 meter. From 6 meter, sorry, this one for at this position it was 6 meter at the initial position, because the man moves towards east, and finally he arrived here at this position 2 meter. This one is the final position, this one is the initial position. Then the displacement is equal to change in position, that means x final minus x initial, which is equal to x final 2 meter minus x initial it was 6 meter, which is equal to minus 4 meter. What is minus 4 meter? The minus 4 indicates the direction. That means we can write 4 meter towards where? Moves towards west. We can write west, or we can write left. Okay. So I think it's clear. The next point, a cyclist rides 3 kilometers west. Look, a cyclist rides 3 kilometers west, turns around and rides 2 kilometers to east. A, what is her displacement? B, what is the distance she rides? See what is the magnitude of her displacement, magnitude, the value. So in this case, what we will do now, let's see. The cyclist moves from 3 kilometers west toward this direction, 3 kilometers west, and then rides 2 kilometers west, then return back to the east 2 kilometers. Then A, you are asked what is the displacement. The displacement is calculated by S is equal to change in position X. That means X final minus X initial. In our case, what is the initial? The final X final. The X final means the final position of the cyclist. Finally, 2 kilometers. Okay, the final 2 kilometers minus the initial position starts from where 3 kilometers west, 3 kilometers, which is equal to minus 1 kilometer. Or we can write here we have to put arrow. The displacement is equal to the negative sign indicates the direction. This negative sign indicates the direction. We can say positive 1 kilometer towards where? Towards west. Okay. B, the second question. What distance does she ride? Means it's easy. B, the distance or the total distance she traveled is equal to simply adding all the initial and the final distance. The initial distance 3 kilometers plus the final 2 kilometers, which is equal to 5 kilometers only without direction, because distance is a scalar physical quantity. C. What is the magnitude of her displacement? Magnitude of the displacement, her displacement. The magnitude means the value is equal to only the value is 1 kilometer without any direction. Okay, good. Let's see the next point. Okay, let us see this simulation example. Look, a person starts from point A to and walk to point B, then back to point A, and then back turns to point C. Look at the simulation again. Point A, again point B, then back to the initial position and get to back minus 3 meter. Okay, now you are calculate the distance and the displacement. Okay, let me put the screenshot, and then to calculate the distance, already we know that the distance S, the distance is a scalar physical quantity, which is equal to simply adding the total path that the person moves. Okay, the first position from this position is the initial position to this position the person moved 4 meter, and then again the person back to A, again 4 meter, and again back to the final position, minus 3 meter, because in coordinate system for the displacement it's minus 3, but the distance it's 3. Okay, just add all the distance that the person covers. Okay, we add the first 4 meter plus, then from point B to point A 4 meter plus, then from point A to C equals 3 meter, in total 11 meter. Okay, this is the distance. Okay, the total path that the person covers. Okay, the displacement, it's a vector physical quantity, is equal to, how do you calculate? Look, the person moved from point A to point B towards the east 4 meter towards the east. Again, from point B to point A, again towards west it's negative 4. That means from point A to point B, then back to A, his displacement is 0. So then from point A to point B, I mean to point C, the displacement is minus 3, because minus 3 is toward the west. Uh, that means the displacement is minus 3. Just look at minus 3 meter. Look at the path that the man covers, okay, or the person covers. That means this part is the displacement from point A to point B, because the person returned back to point, the person goes from point A to point B 4 meter, then towards east, then back to west 4 meter. Here the displacement 0. Then finally the final position from point A to point C, the person goes minus 3 meter. Okay, so minus 3. This minus 3 indicates the minus sign, indicates the direction. That means towards the west. Towards the west. Okay. Let me give you one homework, and write down on the comment section. Okay, write down the answer on the comment section. Okay, let me show you. Look at this motion. Look, a person starts at A and walk to B 8 meter, then the person turns and walk to C minus 6 meter. Determine the distance and the displacement. Okay, let me show you again. Goes from point A to point B 8 meter, then back and walk from point A to C minus 6 meter. Determine the distance and the displacement. That's all about today's lesson. Until then, see you. Bye bye.